Okay, ladies and gentlemen, hello and welcome to our series, AI is the New BI. This is Eric Kavanaugh, your host. We're going to be learning from a lot of different software vendors about how they're using machine learning and artificial intelligence to enhance their products. And I'm very pleased to have Stuart Schulman with me today. He is the founder and CEO of a company called Texifter, and he's got a tool called Discover Text, and that's what we're going to learn about. So Stuart, show us what you got and tell us how it works.
Thanks very much, Eric. Thanks for having me on the show today. So I'm just going to create a new project from scratch here and collect some data in real time. Since the topic is machine learning, I thought, why don't we collect some mentions of machine learning off of Twitter and see some of the things we could do with them once they start coming into the system. So just launching a blank project here. I'm going to click on the big import data button. And you can see here an option to sign in using a Twitter credential. I'm going to use a Twitter credential to connect my Discover Text account with the Twitter Search API. I'm going to go into that Twitter Search API and set up a fetch, what we call a fetch. And the results from fetches go into archives. So I'm going to give it a name, machine learning. And it's just as simple now that I'm logged in as entering my search term. And actually, in your world, where you don't own the company, you'll have a number here like 100. And you can set the rate at which we go fetch every 15 minutes is the fastest you can do it, and you don't need to tweet about it, though we like it when you do. And data is going to start coming into the system in real time. And if you click on the number of units, it's going to bring up the list view of the data. And when you're in the the management page, if you click on the name of the archive, you're going to be exposed to certain functionality, which we will come back to in a second. As you can see, this archive is growing in real time. So let's go in and take a look at some documents in this collection. So we use the Twitter display for, very interesting. There we go. We use the Twitter display. I'm not sure quite what's going on there with the first one. Let's see. There it is. Okay. So this is real-time collection of tweets using the Twitter display, which we think is important from the analytics point of view. For seeing the context in which the body of the tweet is embedded. So it might be a link to something on the web, it might be a news story, it might be a picture, all sorts of things. So that's the item view. We also got the metadata view here. This is the metadata associated with the items. And we've got ways of drilling in using filters. So we might be interested, what are the big hashtags that are happening in this collection? We can just click on there and see that the top hashtag is in fact machine learning and AI and ML. We can drill through there, and if we wanted to start building a subset, we could do it through a filtering mechanism. We could also go back to just the list view, return to list. Right. We could do that by a search as well. So we might be interested in Python. I don't know if there's a lot of Python in there. I could find out pretty quickly a few tweets about Python. And if I wanted to, I could put those tweets into a bucket called Python. All right, so part of what we're doing is the collection piece, and part of what we're doing is breaking the collection down into specific subsets using filters. And there's a number of ways to do that. One of the things I'm going to start here is just we call the Cloud Explorer. We'll come back to that in a minute. Shouldn't take long. It's a small collection so far. And it is a collection that's going to, get bigger every 15 minutes as it hits the search API. I'm going to run duplicate detection as well. That's going to take not too long to run. I'm going to show you the time track explorer. We might be interested in how data is appearing over time. We might want to, when we see spikes, drill into a spike and build a filter directly out of a spike. And as we can see here, just by clicking through that graphical user interface, I've created a filter of 60 seconds here in my advanced filters. Now, advanced filters is where a lot of the action goes on in Discover Text when we're creating samples. Excuse me, just took a drink there. For example, we might want to stack a couple of filters together. So we might want to know, say not in this 60-second period, but over a minute or an hour, what all the hashtags were that were appearing at that particular time, or some other feature of the data. So a big part of what we're doing in Discover Text is allowing users not just to collect data, but also to build samples that they can then use in their research. A little bit surprising that there wasn't more data. In fact, that could be a byproduct, just to walk you through the process again, of using the hyphenate. Right? So I might have also wanted to look for instances of machine learning the exact phrase with no hyphenate, which wouldn't have been captured by that original rule. And you could, in fact, make much more complex rules if you want, but this is the exact phrase rule. We've got a link here to the Twitter documentation, so on. So that's how we collect data and bring it into the system and begin to sample it, to explore it, and go back to this first project. Take a look at what we call the go ahead.
Yeah, real quick, I'm guessing that one of the things you can do is to dedupe exact text tweets and thus kind of track down bots and filter those out. Is that right?
So it's a complex question, but this is the result of the deduplication against this small archive. Obviously, when the projects are bigger, the groups that are the biggest dupes can get quite large, thousands, tens of thousands, even hundreds of thousands. So these are the 8 retweets of this tweet that have been collected. And as I said, this is one way of drilling into the data and creating filters. Like one of the things we allow people to do is to take one item out of every group, right? Like say all items. I always call this sampling method seeds and singles. I don't take the duplicates, I just take the singles, and then one item from every group and create a bucket out of that. So we're often creating buckets of seeds and singles. In terms of the bot detection part of what you're asking, we've got a whole separate project we're doing a bot briefing book on, and there's a group of students who are exploring the problem from a number of sort of interdisciplinary angles. It's a tough one because of all the gray area between humans behaving like bots and bots behaving like humans, and humans using scheduling services, you know, a pure bot, a semi-bot. There's a lot of gray area, and once you start drilling in, it becomes challenging to create operational definitions. Getting back to, does that answer your question, Eric?
Yeah, it sure does.
Okay, great. So yeah, a big part of what we're doing is supporting the collection, supporting the sampling. I mentioned that we built this sort of new, this is what this used to be. It was just a traditional tag cloud that you could interact with. You could remove a tag permanently, and that would change, or for a session, that would change the distribution. I never liked these things. I mean, it is useful, you know, discover things you weren't looking for, and go in and have a look at them. But what I, get back to something interesting. There you go. But what I found more interesting than, you can edit this all, or maybe not, is the list view, right? And not just list view, but bigrams. Here's the most common bigrams, trigrams. This is a nice way to jump into data, too. So all of these methods represent the sort of ways in which we might create subsets of raw data that we call buckets. This was the bucket I created earlier, seeds and singles. And maybe what I want to do is start labeling this bucket. So I'm going to create a data set, seeds and singles relevant to AI. Right? And question mark. So this is a new data set. At this stage, I can create a random sample out of this bucket of these 234. I could say, just give me 50 or 100 items, picked at random. I could create a new code set or use one of my existing code sets. Actually, we have one which is just bot or not bot. But what I'm going to do for the demo here is just create a new one with various styles of coding, which in a 15-minute demo are tough to get through. But the most important thing to know is it could be, you know, pick the winner, right? Or pick all codes that apply. It could be a complex hierarchical scheme. It could be a user-defined grounded theory approach. And then these coding types just mean this is when we want to compare the work of multiple coders. And Eric, I'll send you the paper on Quota Reg and what our approach is there. That's the default coding type. But we also have a triage coding type that's great if you're not doing things like measuring the inter-rater reliability between coders and adjudicating differences. And I'm going to say that this is relevant. So it's the label that I'm creating. This is not relevant. This is one of our most common code schemes, right? And I'm going to say that this is relevant to ML. Simple labeling, binary scheme, 100 units, picked at random, 2 codes I just created, 1 coder, that's me, but if I wanted, I could assign, I've got dozens and dozens of peers who are connected to me on this. It's a network, basically. DiscoverTech's a network. When you form a peer connection, it's similar to forming a connection on LinkedIn for professional reasons or Facebook for social reasons. It's just, this is an analytic network rather than a, I'm sorry, some music just started playing in the background, screw me out. This is an analytic network, not a professional or a social network. Anyway, so I'm going to just show you the coding mechanism, which is one of the key pieces of our system. So this is the tweet being displayed in the coding. We've got the labels, relevant, not relevant up here. Cashbot, that's kind of interesting. It is relevant, I think, to what I'm interested in. So I hit the keystroke 1. This looks like kind of spammy, kind of event thing, not really relevant. Master machine learning might be relevant. And then go through, and as you can see, you can label quite a few items fairly quickly. I'm not really holding myself to any standards here. But typically we like, you know, you could have 3, 4, 5 categories, but we like these binary code schemes. I'm just going to rapidly label a group here, a dozen. Stop. Because they produce the best classifiers. And we do have method to split, you know, once you get all the relevant, you could split and then deal with all the relevant data. But the basic idea is I've just coded 11 items, which isn't really enough to train a machine classifier. And if I want to quickly launch, it's going to incorporate those 11 training items, and it's going to classify, this quick classify button is going to classify the first 500. What that allows me to do then is create a new criteria for filtering, right? And that criteria for filtering is going to be real messy right now. But over time, you know, what this allows us to do is through successive rounds of labeling, we're able to identify items that are very likely to be relevant or very unlikely to be relevant or very likely to be in a topic or not, or very likely to be bots or not. And this is how we train. We train by sampling, labeling, doing machine learning, and then using those machine classifier scores, right, against a bigger set of uncoded data, and then we'll filter based on those scores. And then after filtering based on those scores, we'll sample again, and we'll do another round of coding. And one of the distinctive things about our approach is that when we first started building this software, there really wasn't a very good mechanism for recording human observations for training data. A lot of people still do it using spreadsheets. There are qualitative data analysis software packages out there, and I used to teach, them, I used to use them, but eventually we decided that the things that we wanted to do were best done by building a platform that was just for that. So when we first started building, it was this free open source platform called the Coding Analysis Toolkit. At the center of DiscoverTech That is this free open source toolkit that's been on the web now for more than a decade. And it's got over 2 million items that's been coded on it, and over 200,000 adjudication choices, which is when we look at the work of multiple coders and decide who was right and who was wrong. So inside the the beating heart of DiscoverText, which is a much bigger and commercial, more interesting product, is this original piece. And just today we published a blog post, I don't know, off topic, where we went to look for scholarly citations of this free open source coding software. And by golly, if we didn't find quite a few, across the discipline. I mean, some on methods, some on data analytics, but economics, education. Look at this list. Health science, this was the one that really got me. Our software has been really widely used in the health sciences.
Wow, that's great. Yeah, that's good stuff. And could you go a bit more into the machine learning? What kind of algorithms are you using, and what are they doing? I really like the fact that you've built a platform to combine the human interaction of coding with the machine learning algorithms to train them. Could you talk just for a minute about what ML is doing under the covers here?
Sure. To get the actual nitty-gritty, you'd have to look at the documentation for your classifier. So it's a naive-based system, right? But it's theirs. So we license it. It's their documentation that would best describe what it does and how it works. But I will say that we have found it to work in just about every case. There are very few scenarios, and just getting it, what people have asked us, why don't you use SVMs, or why don't you use hybrids of multiple different classifiers to get the op? And the reason is because we have users from so many different domains, so many different languages. Nothing we've ever tested has ever worked as universally well as a simple naive Bayes approach, right? It's just, it works on everything, quite simply. And that's why we use it. Now, could you improve the quality of the result by combining it with another classifier or, hybridize? Certainly. But that's not really what we specialize. The reason why I walked you through the whole CAT thing is because we don't specialize in a classifier. We specialize in the training data. That's our secret sauce, is we know whatever classifier you use will be better if you have higher quality training data. And our patent, and the colloquialism is Quota Reg, is based on an idea that's very similar to Google's PageRank, right? So if you, I think there's a easy to find blog post called Quota Reg is a big idea. And the reason it's a big idea, there we go, is because we basically looked at the universe of humans. It's in the paper I can send you. We looked at the universe of humans and figured out that there's very few that are good at labeling data. And there's a lot that are bad, and everybody else is average. Once you accept the normal distribution of coder attributes as a fundamental law of the universe, then you kind of quickly come to the conclusion that if you're labeling data, you really need the people who are best. You need the best labelers. And if you happen to just take two random labelers, who are your students or your friends or whatever, the RAs that your faculty would assign to you, there's no guarantee they're not the two worst in the world.
Wow.
Probably not. But they're probably average, right? There's a very small chance that they're the best. And our idea about Quota Reg is you should start with a big pool, problem solve the training set. And through that problem solving of the training set, you should rank your annotators. And when you get down to the nitty gritty of making your when you're not testing anymore, when you're actually training, creating your final annotations, either only use the best or the top third or whatever the numbers are, or this is the idea in our patent, weight the best annotators more heavily.
Yeah, that's a really good point that you just made, and I'm glad that we had you on this show to kick off our whole program here, because you've really driven home the critical importance of the training data and of getting that right. Because if you train your algorithms on bad data, or let's say suboptimal data, you are going to lower the efficiency of the algorithm, right? The whole point of getting an algorithm to do the right thing is that you have to use good training data, and I think you really kind of nailed that to the wall here, right?
It's even more important than just that, but you're absolutely right, which is that you don't even know what an accurate algorithm is until you know who the most accurate humans are. Because, you know, if you don't have the gold standard set, then what are you measuring the algorithm against? A flawed human?
That's right.
So there's a whole process for creating agreed upon gold standard training sets. Computer scientists are very, you know, up to speed on all this stuff. They could run circles around me on probably half of it, most of it, all of it. But everybody else is not. Everybody else who's trying to do machine learning for the first time did not get a computer science degree, you know, does not know the value of good training data or the difficulty of actually getting it. And even some of our computer science friends use, you know, mechanical Turk and get training data that is of a very mixed quality.
Wow.
So all we're out here pushing for is, it's actually, there's a great paper. I'll show you one PowerPoint slide before you kick me off. But there's a great paper. Where is it?
Yeah, and folks, it's Texifter.com to learn more about the technology. That's TEXIFTER.com. Text data science software. This is a good demo of playing with Twitter data and really cutting through the noise, right? That's the key, is to cut through all the noise on Twitter, which is not insignificant, to get down to the meaty stuff that's actually going to get you somewhere.
Yeah, and I had to end with this, which is probably the best paper I've ever read, and it's a paper that describes 13 years of my life when it came out in 2013. And I talk about it every workshop I do. And the basic idea is that getting these annotations has never been easy. Managing the groups is hard. Validation is the key, right? And some things are easier to validate than others. Some models, I'll give you, we were doing traffic report classification. Is a tweet a traffic report or not? That turned out to be super easy. Then we were doing, you know, is the tweet of interest to the police? And it turns out to be super, super hard. Right? So some models are easy, some are hard, and the main point is that you've got to validate, so that when we start building CAT in 2007, we were encountering all of these problems, but we were doing it pen and paper or with commercial off-the-shelf software that wasn't for the problem, and that's why we built CAT.
Yeah, and what we're really talking about here is highly supervised machine learning. Is that a fair statement?
That is. It is. It is a highly supervised sort of iterative approach of developing a model. I mean, even the traffic one, which was easy in the long run, you know, we put together about 10,000 training items in under a week, and it was a super easy one. At the beginning, we really didn't know what a traffic report was, right? Somebody looks out their window, takes a picture of the snow, and says, "There's going to be traffic today." Is that a traffic report?
That's funny. Well, no, but I really like that you've stressed the importance of validation, because really, if you sit back and think about it for a second, there's a bit of a chicken and egg kind of syndrome here with building these models and using machine learning, because unless you are careful in how you set up that training data, you just don't know where it's going to go, right?
Exactly, which is why we agree with Plato. That when you create categories, they're going to piss somebody off, maybe everybody, and they're going to make kind of miserable. And software doesn't make the problem of categories go away, right? What we do is we measure how fast people apply the categories. Are they valid? Are they consistent over time? And when a machine is learning, you know, is it producing results that are similar to what the humans can do? And that's really what we go for. We never get a classifier that puts everything in the right bucket, but we got the traffic one after a week to put 96% of the stuff in the right bucket, which was super great. And then this is the process. Like, here is an example of when 5 coders, annotators, have labeled the same Chinese microblog post, and 4 of them say it's about the shoot down of an airplane, and 1 of them says it isn't, and the airplane was MH17. Here is where we record who was right and who was wrong. And right. It's basically a second level of coding. So we've already recorded these initial 5 observations on this one tweet, but then we come through and we adjudicate, and that ends up producing the ranking. And then we can see, like, that coder was really bad, and some coders are really good. And that this distribution exists even when you've got, you know, just coders who are medium good, and great. There's always going to be that kind of distribution. And our argument is that if you're going to use humans, you should use more, not less, so that you can rank them. And then when you rank them, lean on the best ones.
Wow, that's great stuff. All right, we'll close it out there, Stuart. Thank you so much for your time today. This has been a fantastic demo, and you reminded me of some really important things, right? That's an old cliche. People don't need to be taught so much as reminded, and you reminded me of some really important stuff here. So thanks for your time. This is Stuart Schulman of Texifter. Well done.
Thank you very much. Thanks, Eric. Have a great day.
Okay, folks. Take care. Bye-bye.